In this lesson, we'll talk about class design guidelines with Java. As you're learning about object-oriented programming and watching the other lesson videos, learning about inheritance, abstract classes, interfaces, these guidelines provide you good practices for designing your class definitions. Okay, so first is cohesion. Now, your class should serve a coherent purpose. For example, if you're defining a student class, you shouldn't include methods for teacher in there, right? A class should be consistent. Names for classes, data fields, and methods should be informative and have some meaning, right? You want to put the data fields first, followed by the constructors, followed by the methods when you're defining classes. Make names consistent, right? If you are going to have toString, for example, for all your classes that return a string representation of the class, right? Always provide a no arg default constructor. This is from the lesson when we talked about constructor chaining. This becomes very important, right? Encapsulation, right? Use the private modifier to hide data from direct access, right? That way, later on, you can change, maybe use a different data type as your class definition evolves, right? Provide getter-only methods for data fields that are only readable. Provide setters for things that are writable, for data fields that are writable. A class that implements the clonable interface must override clone, right, from the object class. Otherwise, it won't be available outside the class. Clarity. Class should have a clear contract with the outside world to be easily explained and understand why it's being used or what its purpose, right? Methods for the classes should be independent of each other. You should be able to invoke them in any order, right? Method definitions should be intuitive. The signature should be intuitive and make sense. Here's an example where it is not intuitive. The string substring method, static method, provides begin index and end index to get a substring. However, it gets the substring from begin index and from end index -1, which doesn't quite make sense, right? So that is an example of poor definition, not really an intuitive definition, right? Don't have data fields that are derivable from each other, right? So if you've got a birth date, a data field, you don't need an age one. You can always derive it. Completeness, right? A class should be applicable to a wide range of use cases, right? You want to provide different ways to customize and use it for lots of different kind of applications, right? Static versus instance, right? So a method that is not dependent on an instance variable should be declared static, right? There's no reason for it not to be static, right? When you're referring to static variables and static methods in your code, use the class name dot before to show that it is a static variable. It makes it very intuitive when you're reading code, right? Do not initialize static variables in constructors, right? Because then every time you create an object, they'll get overwritten, right? It's a shared variable, right? Now, inheritance versus aggregation can be confusing to people. The difference between is a relationship, which is inheritance, and has a relationship, which is aggregation, can be confusing, right? So, for example, person and name, a person has a name, so that's an aggregation relationship. Apple is a fruit, right? That's an inheritance relationship. If you define an object a class called fruit, the subclass might be apple, right? Which will inherit from fruit. Okay, interfaces and abstract classes. These can also be very confusing. Both are used to specify common behaviors, right? Now, classes have inheritance, which is is a relationship, like orange is a fruit, right? Whereas interface inheritance is a weak relationship. It's used to represent, property of something. So, for example, a circle might have a property that is copyable, right? It is clonable. Interfaces are more flexible than classes because you can implement multiple interfaces, but you can only inherit from one other class, right? So now a common pattern you will see is that when an interface is provided with some abstract methods, there'll also be a concrete class that implements that interface. So you have the option to use the interface by itself or actually have a actual concrete implementation, right? So that's been kind of a high-level overview of class design guidelines or principles. Thank you.